Hello everybody, my name is Carlos Esparza. I'm from Mexico and I'm here to present you the results of our research named Rice Husk and Coconut Fever to improve heat capacity in green wall substratum. The increase of the demographic population in small cities has forced buildings to modify their proportions into a more vertical than horizontal way. These changes make facades the most important element in heat transfer between the interior and the exterior. Various solutions for the facades have been developed to mitigate and reduce heat transfer. One of them could be this double skin facade. Also, vegetation has been constantly used as a heat mitigation instrument in architectural envelopes and open spaces, as it can absorb up to 80% of the solar radiation through various natural processes. This paper presents the analysis of an experimental substratum composed of 50% of rice husk and 50% coconut fiber for a green wall in a novel prototype of container for vertical vegetation. Variations in thickness were made to identify the affectation in the inside dry bulb temperatures for the experimental cells. The experiment was carried out in the city of Colima, Mexico, situated on the west coast of the country in front of the Pacific Ocean. Its geographic location are 19.5 north latitude and 103.5 west longitude, and 350 meters above sea level. The characteristic climatic conditions were hot and subhumid, with average temperatures of 27 Celsius degrees and average relative humidities of 60%. The place used was the experimental campus of the University of Colima. It was performed in the experimental cells. 4 experimental cells were used simultaneously, 3 as cases and 1 as reference. The inside dimensions of the experimental cells are 1.35 meters all sizes, with a small entrance in the north. The constructive characteristics such as materials are described in the next table. The prototype was an hexagonal frame made of aluminum sheet of 3 millimeters wide, as it is shown in figure 3. At the bottom and the upper faces, there is a composed layer of felt and steel mesh that retains the substratum and reduces the loss of water in it. Between the composed layer, it is placed the substratum compound of 50% rice husk and 50% coconut fiber. The use of these natural fibers as a substratum is due to the exploitation of waste material from primary activities in the region. The variable analyzed was the thickness of the substratum in 3 values of 10 centimeters, 15 centimeters, and 20 centimeters. The green facade was composed of several prototype devices. Then the prototype was placed in a swarm arrangement in the south and west facade, as it is shown in figure 4. These 2 orientations are the most affected facades by solar radiation for this latitude. The geometric form of each prototype allow us to place each next to the other 6 containers to improve load resistance and heat transfer between them. The green walls was placed directly over the walls without any further preparation but painting. About variables and equipment, the variables monitored were the dry bulb temperature and the relative humidity inside of the experimental cell. Inside the cells, data loggers U12-12 from onset comp were placed at the volumetric center of each cell. The frequency of the monitoring was 30 minutes over a week. The results of the 7-day performance is presented in this figure. In black, the results of the reference cells are presented, and it can be seen that the maximum temperatures swing between 36 Celsius degrees and 38 Celsius degrees. The best performance in terms of maximum temperatures are presented in thickness 10 and thickness 15, with temperatures between 32 Celsius degrees and 33 Celsius degrees. About the lowest temperatures, the reference cells present the lowest temperatures, and about the difference between all the cases are not really important to mention. Then the representative data is presented in this slide. As the other results, the worst performance was the reference cell with a maximum temperature of 37 Celsius degrees and a minimum temperature of 21 Celsius degrees. In other hand, the best results were presented by the thickness 10 and thickness 15 with maximum values of 32.5 Celsius and minimum temperatures of 22 Celsius degrees. Between the worst and the best performance, there was a 6 Kelvin difference in the thermal swing between the reference cells and these two cases. As a conclusion, it can be seen that cases with thickness 10 centimeters and 15 centimeters work slightly better in terms of thermal damping and thermal swing against the other case that was the thickness of 20 centimeters and the reference cells. It is important to declare that this kind of solutions does not reduce inside temperatures, but reduces the heat gained by radiation from the outside. Also, the use of this kind of prototype as a green wall allows sectioning the vegetation, giving the opportunity to plant different kinds of herbage. And finally, about the substratum, it is possible to use rice husk and coconut fiber as substratum and reduce the waste of these materials.